Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on this podcast we affectionately call Space Nuts. That's because we're all nutty as fruitcakes, but we love it. And it's great to have your company once again. And joining me, as always, is Professor Fred Watson. Hello, Fred.
Hey, Andrew, fellow space nut. Good to talk to you.
Yeah,
what a surprise.
Many more in the packet than when this started. It started as 2 in the packet. Now there's I don't know, several thousand.
6, 7.
Which, no, it's a lot more. I'm actually going to push the humour aside for a moment and say it is just fabulous to be having so many downloads per week, thousands upon thousands, and it is remarkable. And I'm just so chuffed and thrilled that people are enjoying the show, and we're getting some nice messages. We got one yesterday from someone who said, I don't know anything about astronomy, and I've been listening for a while now, and I've learnt so much, but I really enjoy the way we deliver it. So that's terrific. I'm glad we've found a formula that makes people happy. Now, Fred, how are you?
I'm very well, thank you.
That's good. You've been OS.
Slightly jet lagged. That's right. Yes, so I flew in yesterday from Berlin because I've been in Potsdam, which is a city right next door to Berlin, which is the home of the Leibniz Institute for Astrophysics, which is one of Germany's premier astrophysics institutions. And why was I there? Because there was a meeting there of scientists who have been associated with the RAVE survey. And you might remember that RAVE is an acronym for the Radial Velocity Experiment, which is a survey of, actually it turned out in the end to be 500,000 stars. And it gets its name from the fact that we originally set it up to measure radial velocities, which is the velocity of a star along the line of sight. When we started back in 2003, there were radial velocities known for only about 30,000 stars, 20 or 30,000 stars. And so we increased that by measuring 500,000, but there are new surveys on the horizon which will push that up even further. In fact, one that we've talked about, the Gaia satellite, which is measuring stars in hundreds of millions. Nevertheless, the RAVE survey was a groundbreaker. It did marvelous research. We've had, since the survey was finished back in 2013, something like 160 papers have been published about the results from it. So this meeting in Potsdam was the kind of shutdown meeting for the survey. And I guess there were about 40 scientists there, all of whom have been involved one way or another with the survey, including the principal investigator, Professor Matthias Steinmetz of the Institute of Potsdam. He led the survey. There was a project scientist whose name is Tomasz Witter. He's based in Ljubljana. Tomasz is a good friend of me and the survey as well. And the project manager was somebody called Fred Watson, who was based in Australia, because I've heard
good things about him.
You've got to watch him, though. He does podcasts, you can't trust anyone.
You can't trust a podcaster.
No, absolutely. So it was great to see everybody, to talk about the science that's come from the survey. There were something like 20 presentations. I did one about what has happened in Australian astronomy since we stopped the survey, which was back in 2013. Of course, there have been huge changes to Australian astronomy, many of which you and I have spoken about. But everybody was interested in that because it's got a very European-centric clientele, if I can put it that way. The members of the team, many of them are in Europe. There's a handful in the USA, a handful in Australia, but it was very much weighted towards European scientists, which is great because Australia now is very close to Europe in the scientific sense with our strategic partnership with the European Southern Observatory down in Chile. So great stuff, and I'm delighted that I could go. It was a long trek homewards, but I managed to make it all in one piece yesterday morning.
Yeah, it's a heck of a trip. I did it last year, and I suppose all up, you're basically travelling for 24 hours solid to get from Heathrow to Sydney or whatever. Yeah, it's pretty heavy.
But the thing that I sit on these flights and think it is astonishing that we can do that, given the way things were. Well, when I was a kid, 60 years ago or whatever it is, actually it's more than that. It was. You took 5 days to get to Australia by air, and you had stops all the way. And now we just sit in an environment. We sit in something the size of a village hall, and we're completely, apart from the odd bump of turbulence, completely unaware of the fact that we're going around the world. It's just. Well,
you go back 100 years when my grandfather went to the Western Front. He left Sydney, and it took 3 months for him to get to England.
Yeah.
By boat. They didn't have aircraft back then that could carry people that far in great numbers.
Absolutely.
So, pretty astonishing that we've done so much so fast. And that leads us to some of the topics we're going to talk about this week. The first one is Snoopy. Now, Snoopy is a module that they actually lost as a part of the Apollo project. And given that we're coming up on the 50th anniversary of the Apollo 11 mission, it's appropriate to look at this because something's happened with Snoopy, interestingly enough. And I suppose I should let you know that Fred's leaving the country again. Very, very soon. So we're going to have to do some cramming. So we're just going to do, for the next 3 episodes, shorter, sharper episodes and try and bump off a whole heap of questions in the process. So I hope you understand that. The other thing that's rather impending is the situation that might involve the door behind me. My grandchildren are due here any time, and as soon as they arrive, all bets are off. There's no way I will be able to do any more podcast recording because they won't let me, and they won't be quiet.
Right too.
They will not be quiet. They are 4 and 2, and that'll be the end of that. So we've got to get cramming. So let's get stuck into it, Fred. The Snoopy module. Now, this was Apollo 10, wasn't it?
Yeah, that's right. Apollo 10, the mission that, not surprisingly, immediately preceded Apollo 11. And it was basically a test run for the Apollo landings in July 1969, the first Apollo landing in July 1969. It was Apollo 10 flew a little bit earlier the same year, and it did the whole deal, went to the moon, but didn't land. So what happened was the spacecraft orbited the moon as planned, and exactly as they did in Apollo 11. And then, so of course, the Apollo spacecraft were in several modules. The command module, which was the conical bit, which actually is the only bit that came back to Earth. The command module on Apollo 10 was named Charlie Brown, after the cartoon character. And so the lunar module, the bit that went down to the lunar surface, had to be called Snoopy because that was Charlie Brown's dog. So it did all its stuff. It followed all the protocols, touched down to within 50,000 feet of the lunar surface, which was the point at which normally the descent module would kind of kick in its rockets and start the touchdown procedure on the lunar surface. But instead of doing that, what they did was they mimicked the return flight from the lunar surface to the command module, which of course was in orbit around the moon, so that the upper part of the lunar module was basically what brought them back to the command module. The lower part of the lunar module actually crashed on the moon. That eventually crashed on the moon. But the upper part, the bit that carried the astronauts, having docked with the command module and the 2 astronauts who were Tom Stafford and Gene Cernan, transferring back into the command module, namely Charlie Brown, what NASA did fired the engine of the lunar module, Snoopy's engine, to take it out of lunar orbit and basically put it into orbit around the sun.
Oh, wow.
And then they, there was no real reason to keep going with this. So they essentially forgot about it. And having done that, nobody really thought about it anymore. The mission continued according to plan. The astronauts came back to Earth in that beautiful dress rehearsal for Apollo 11. It's only, I guess, recently that people have started thinking, I wonder what happened to Snoopy. And in particular, an amateur astronomer, although he's a fellow of the Royal Astronomical Society, the peak body in the UK, he has done a lot of work on trying to work out where Snoopy is, partly in terms of calculating, whereabouts it might be given the orbital parameters that we know about Snoopy in its orbit around the sun, but then trawling through all the data on the web, which comes from the world's big telescopes, because basically when you do a survey, for example, the RAVE survey, even though that was on stars and the intimate details of stars, the results are now all publicly available on the World Wide Web, on a RAVE website hosted in Potsdam. So the same is true with all the big telescopes of the world. The data are effectively public now. And so Nick Howes, the amateur astronomer who's led this project, has trawled through all that stuff to find evidence of a slowly moving object, a faint, slowly moving object in the right part of space, and says he is 98% convinced that he's found it.
So where is it?
Well, it's kind of in orbit around the sun.
So it is in orbit around the sun, he thinks.
Yes,
as planned.
Where it ought to be. That's right. I think actually Nick Howes must be a mathematician of some note, because he estimated the odds of locating the module were 235 million to 1.
Wow.
So he's 98% convinced that he's found it. That it would have needed, you could limit it to a certain part of the sky, just knowing the parameters of what an orbit is. It takes a year for something to get around the Earth, and you know where it set off from. So it gives some idea of whereabouts it might be. Sorry, did I say orbiting the Earth? I mean, it takes a year for an object in an orbit around the sun to go around once. That's what I meant to say. Sorry, I'm just playing it back in my mind and realizing that I'm jet lagged and talking rubbish. Anyway, they trolled through all this stuff and convinced they've located it. The problem is, how do you prove it? Yeah. And, this is really difficult. There's not an obvious way to do it, because this is a small object. It will come relatively close to Earth, but you've kind of got to wait for that to happen. And maybe the best bet would be radar observations. We often find images of asteroids, near-Earth asteroids, which have been made by some of the big radio telescope dishes in the world. You can use them as radar scanners, basically, and probe the surface of something like an asteroid. But this is much smaller. This is 3 or 4 meters across at most. It's not asteroid sized. I think what is perhaps at the back of this team's mind is that maybe, just maybe, one of these extraordinarily wealthy space enthusiasts like Elon Musk or Jeff Bezos might just mount a mission to send a spacecraft with a camera on board to have a look.
Yeah, maybe.
Would be fantastic.
Yeah. What sort of condition would it be in now?
It should still be pretty good. It would be, it's got 50 years of bombardment by the sun's radiation and by the solar wind, but that takes many thousands of years to make any real difference to a metal surface. So I think it would be in pretty neat condition, actually. There is a nice quotation from Nick, the person who's led this project, Nick Howes. He's spoken to actually to Gene Cernan. Now, I think Gene died a couple of years ago. I think we might have covered that in our Space Nuts podcasts. But what Nick Howes has said is I would love to get Elon Musk and his wonderful spacecraft up and grab it and bring it down. And then he goes on to say, as Apollo 10 crew member Eugene Cernan said to me, son, if you find that and bring it down, imagine the queues at the Smithsonian.
Yes, yes, indeed. Yeah, no, it would be amazing, but very, very costly project, I would think. So
yeah, it would be for what amounts to space archaeology. This falls within the province of now called space archaeology.
Well, now, and because it's over 25 years old, it's also classified as a vintage device, isn't it?
That's right. Yes, just like you and me.
Yeah, very much so. Well, let's wait and see what happens with Snoopy. But he sounds like he's pretty confident that he's spotted it or knows where it is, and who knows? Maybe someone will retrieve it, or at least go and have a quick squiz and take some nice photographs of it. You're listening. Oh, and of course, with the 50th anniversary of the moon landing ever so close, we're getting pretty excited because I think we're going to have to do a fair bit of talking about that, Fred, when the time comes.
I think you might be right there, as indeed I will be at various locations in Australia.
Indeed. Okay, this is Space Nuts, the podcast, of course, with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated number 1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, just a reminder that you can certainly follow us on YouTube these days. If you're a YouTube user, you'll find our podcast there. We're also on Instagram these days through Bytes.com, BITESZ.com. In fact, I think it's Bytes something. Can't remember. But if you have a look around, you'll find it on Instagram. Facebook as well is where we spend a fair bit of time, and we share a lot of stories there, not just the things we talk about in the podcast, but all sorts of astronomical information. And Patreon, where you can subscribe to our podcast for a fee of your choice and basically support this podcast as you see fit. And we now, Fred, have 20 patrons who are paying for a little fee every month to keep our podcast going, which is fantastic. And they get extra bonus bits and pieces as a part of that, and they also get the commercial-free version of the podcast at Patreon. So that's patreon.com/spacenuts if you want to take a look at that. Now, Fred, let's get into a couple of questions. And the first one comes from Justin Blair. Hi, Justin. Hey, guys, he says, I love your podcast. I'm from Knoxville, Tennessee. we'll overlook that, Justin. And wanted to get your guys' opinion on the Bortes void and what you think is causing it. Well, before we can even discuss what's causing it, we probably need to understand what the Bortes void is.
Okay, so it's named after a constellation in the northern hemisphere, and it's a funny word. It's usually pronounced Boartes, so there's two O's in it. It looks like booties, but it's Boartes. The second O has an umlaut over it to tell you that it is pronounced as a separate vowel. What does it mean? Well, it's the herdsman, the Greek constellation. Got Greek name Boartes. The constellation is the herdsman, and it's basically quite a large constellation in the northern sky. So that's that's where the name comes from. But the void part of it is because Boartes, or in the direction of Boartes, modern surveys of galaxies have shown that there is a void there. There's a place where there are very few galaxies. In fact, we now know it's not empty, but for quite a while it was thought to be devoid of galaxies. So this large volume of space, and it is large, it's about 330 million light years in diameter. Now, just to put this into context, we know that on average in the universe is made, what we see is galaxies. We see lots and lots of galaxies, but they're not uniformly distributed. They're distributed a bit like a honeycomb. And in fact, one really good analogy is to imagine a froth of soap bubbles with empty space in between all these membranes linking them together. And that's kind of what the universe is like, whereas the membranes are made of sheets of galaxies, basically, in which we find not just individual galaxies, but clusters as well. So voids are very normal. But the typical size of a void is about 100 million light years. This one is 3 times the size of that. So this might be what you could call a supervoid. And in fact, some people have called it that. It was discovered by somebody I know, actually, an astronomer called Robert Kirshner, who's at the University of Harvard. In fact, I know him so well, I stole a couple of his jokes that I use in my talks, but don't tell anybody, because he's a lot funnier than me, as well as being being a very clever scientist. He reported it back in the early 1980s. And the reason why he could report it is because he was measuring the 3-dimensional distribution of galaxies in space and came across this place where there was no galaxies. We now know that there are at least 60 galaxies within the Bortes void, but given its size, and if you kind of take a guess as to what you might expect in a void, you would expect many more. So it does mean that this is a very unusual part of the universe. I mean, turning now to the question, what do I make of the Bortes void? It's an unusually non-dense part of the universe, quite rarefied in terms of the galaxies that are there. But the bottom line is it does not contravene our current models of what the universe might look like. So if you say, we kind of understand why you get this soap bubble appearance of the universe, or froth of soap bubble appearance. It comes from conditions just after the Big Bang. So that's why that structure is there. In fact, we can see it imprinted on the cosmic microwave background radiation, that celebrated flash of the Big Bang that you can now see with radio telescopes. So it doesn't contravene our understanding of that. In other words, it's just a big one. It's just a big void, but it's not anything that is prohibited by our theoretical understanding of the universe. So it fits the bill, basically. There's one more comment to make, which doesn't come from me. It comes from an astronomer by the name of Greg Alderling, who is, I think, at the Lawrence Livermore Laboratory, which is part of the University of California? Sorry, not the Lawrence Livermore. That's a different institution. It's the Lawrence Berkeley Laboratory, which is basically Berkeley Lab at the University of California. He has quoted that if the Milky Way galaxy, that means, had been in the center of the Bortes void, we wouldn't have known there were any other galaxies until the 1960s. It's a lovely quote. What it's telling you is
that is really,
yeah, we wouldn't have been able to see any others because our telescopes were not powerful enough.
So we would have really thought we were very much alone in the universe, I imagine.
Yeah, we would. That's right. But of course, we're not. We're in a part of the universe where the distribution of galaxies is pretty normal.
Yes.
It's just that out there in the Vortex void, it's not very normal.
Okay. There you are, Justin. Hopefully that solves your dilemma in understanding the Vortex void. We will move on, Fred, to a question from Sarath Pereira. Hi, Sarath. I think he's sent us questions before, once or twice. Hi, Andrew and Professor Watson. As always, immensely enjoying your podcast. In the wake of the black hole announcement, I have a niggling question for you. A black hole is a sphere surrounded by a sphere of event horizon. When we look at it, we should only see a bright sphere. So why was the photo that has been published, why does the photo show a black void in the middle? We are not looking at a cross-section.
Now, it's a great question. That kind of goes to the heart of our understanding of what a black hole might look like. So actually, a black hole isn't a sphere, it's a point. That's what defines a black hole, a single point in the universe where the density is infinite, which is immediately mind-boggling, but we can move on from that. Because the bit that you can, I think, get your head around is the event horizon, which is the sphere that surrounds a black hole. And that's the sort of point of no return for light trying to leave the black hole or going into it. It's where light cannot cross because the gravitation of the black hole is so strong. So what you might expect to see, if you could see a black hole, would be basically the event horizon, which would look completely dark, sort of silhouetted against the sky. And some depictions of black holes do look like that. But in reality, what we've got is actually the event horizon around which is swirling this disk of agitated material, which is basically being sucked into the black hole. It's what we call the accretion disk. So it's gas and bits of chewed up stars and probably a few planets and things of that sort, all whirling into the center of the black hole. And because
plastic bags.
Yeah, there would be plastic bags in it, definitely, yeah. Yeah, I know.
In fact, I think they're probably immune from spaghettification.
They might be. In fact, that's right. Anyway, be that as it may, they will be circulating very rapidly around the event horizon, and actually, that's what makes a black hole luminous. The fact that you've got this swirling disk of material around it, which is banging into each other, all the bits of stuff, exciting it to high temperatures, and that makes it emit X-rays and, in fact, radio radiation as well. So, in the radio region of the spectrum, which is actually where that photograph came from. It was taken by radio telescopes. What you'd expect to see is this black thing with a big swirling disk around it of the material circulating around it. Now, that's not what you see, and the reason for that is because of the intense gravitational field of the black hole. So, in fact, what you see is a curious kind of silhouette of the event horizon. And it's caused by the fact that the only light that you see, or in this case, radio radiation, is stuff that is only just escaped being sucked into the black hole. So it's skirting right around the edge of the black hole. And effectively what you get is the shadow of the black hole against this light that's just escaped being sucked in. And the lights come from the accretion disk. And so that's why that curious image was a big. It looked exactly. I think it might have been you who described it as looking like a cream donut. That's exactly what it looks like, just a hole in the middle of stuff. And the hole is not the event horizon itself. It's the sort of the shadow or the silhouette of the event horizon on this material, because of the fact that what you're seeing is light that's only just escaped being sucked in it. So it's heading directly towards you. So that shadow is actually rather bigger than the event horizon. In fact, if I remember the figure rightly, it's 2.6 times the diameter of the event horizon. So it's sort of a magnified shadow. And it comes about because of this curious geometry. You've got such an intense gravitational field that our normal ideas of geometry, where if you hold something up, then it silhouettes what's behind it, none of that works. It's all very, very different stuff. But you have to trust me that what we get from seeing it from any direction is this curious silhouette effect caused by the radiation only just having escaped the clutches of the black hole.
So not a sphere.
It is a sphere, but it's a black sphere, and the only reason you're seeing it is because there's a lot of light around it.
Right.
You see the shadow of the sphere.
Okay. Needed to clarify that just for my brain.
And mine.
Yeah. Yeah. I mean, a black hole sounds very much like a kitchen sink to me. It's just everything swirls around and you don't know what's down there.
Quite so. Except for the plastic bags, you always know that.
They'll never go anywhere. Okay. Sarath, I hope that answers your question and demystifies a little bit more the mystery of a black hole. That's where we're going to have to conclude this week's episode of Space Nuts. We're doing a bit of cramming over the next few episodes because of various things. Grandchildren notwithstanding. Thank you, Fred, as always, though. It's been great fun.
Fun to talk to you too, Andrew. What a surprise. See you next week.
We'll catch you next time, or I'll talk to you in a few minutes, depending on which comes first. And don't forget to check out patreon.com/spacenuts if you'd like to be a patron of the show. And that Instagram username for us is Bytes HQ, BITESZHQ. That's our name on Instagram. Bytes.com is the parent organisation of our podcast company. So Bytes HQ. Bytes with a Z on the end. I don't know why, but maybe Bytes was already taken, but there it is. Enough jibber-jabbering. I will talk to you again very, very soon on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.